All right, so on this problem, keyword is proportion. Okay, so we are told that 6 miles and 50 minutes go together. Okay, every 6 miles is 50 minutes, and every 50 minutes is 6 miles. So that's a ratio of two measurements that go together. Now, they say if we do the same rate, so it's going to be equal, then how many miles would 35 minutes be? So the question is, do the 35 minutes go on the top or the bottom over here? Well, or I'm sorry, 35 minutes. Well, because on this fraction, our minutes is on the bottom, then it'll be on the bottom on the second fraction. Okay. The question is, how many miles will that be? If this is equal to what she was doing before, because this this ratio right here basically tells us how many miles per minute she was doing, and we just want to be consistent with that. So we'll cross multiply and get 6 times 35 and 50 times question mark. So that's 210 on the left. And then when we divide by 50, we get 4.2. 4.2 what? Well, we're looking for miles. So 4.2 miles is how long. So on these problems, you set up a proportion. Okay. That is one fraction equal to one fraction. When you have a certain rate established, and you say, all right, well, I want to figure out if I stay true to that rate, how are things going to play out? In this case, if I only run for 35 minutes. And so that's kind of how these go. All right, on this one, it's real similar to the last. Turns out what we have are what's called similar triangles. You can look that up and it'll give you a quick little explanation online, but similar triangles, meaning that one of them is just a bigger version of the other. The angles are the same, the sides are just longer, but they are still proportional. So the first triangle tells us that for every 8.8 feet that we travel horizontally, we're going to go vertically 6 feet. Well, the second triangle is going to preserve that relationship. It says, hey, for every 32 feet, we go horizontally. So horizontal, that's on top. Horizontal, that's on top. And I could have put them on the bottom. I would just have to put them both on the bottom and be consistent. So if I go 32 feet horizontally, how far am I going to go vertically? Well, over here, we know that the horizontal is always a little bit bigger than the vertical. I haven't done this problem yet, but I'm going to guess if the horizontal is a little bit bigger than the vertical, maybe it's going to be around 28-ish, roughly. I don't know. Let's find out. So we're going to cross multiply and go 8.8 times the question mark, and then 6 times 32. And let's see, 180, 192. Okay, time to do my calculator thing. Whoops, wrong button. And I get, well, I wasn't as close as I had hoped. To the nearest foot, 22 feet. It was 21.8. Yeah, anyway, so 22 feet. And that is going to do it for that one. So yeah, on these, you just set them up like proportions again and cross multiply and savor the experience and enjoy me pausing the video. Okay, so on this type of a problem, each of the problems is going to be something like this. It takes hose number 1 to fill the swimming pool in 5 hours if it works alone. And it takes hose number 2 to fill the swimming pool in 7 hours if it works alone. How long will it take them working together? Or if you open the first door in a theater to empty the theater, it takes 2 minutes to empty the theater. If you do the second door all by its, or if the 2 doors are working together, it'll take 1 minute. How long will it take the second door working alone? Something like that. So 2 different things getting a job done. Now, on these problems, you always start off the same way. 1 over something plus 1 over something equals 1 over something. So what are these 3 blanks? Well, this one over here is how long it takes the 2 items working together to get the job done. And then these over here, how long it takes the 2 items working alone to get the job done. So it says left on together, the cold and hot water faucets of a certain bathtub take 5 minutes. All right, so there's our together number. If it takes the hot water 15 minutes to fill the tub, so there's one of the working alones, how long will it take the cold faucet? Okay, so we'll multiply both sides by the least common denominator, which is 15 question mark. And now, let's see, when we multiply that by the first fraction, the 15s cancel and we just get 1 times question mark. Then I'll multiply it by the second fraction. The question marks will cancel and we'll just be left with 1 times 15. And we multiply these together, the 5s cancel, and I get 3 question marks. So if I subtract a question mark from both sides and then divide by 2, I get 7.5. And it turns out 7.5 minutes. And that's how these are done. Every time. Okay, so now we have these, another rate times time equals distance problem. Okay, whenever we see that, then we know we want to use the dirt equation. Distance equals rate times time. Okay, so on these problems, you always have 2 scenarios. Okay, so distance, rate, time. Okay, we always have 2 scenarios. Now, what are the 2 scenarios? Sometimes it's, well, train number 1 and train number 2, or with the plane with the wind and the plane against the wind. In this case, it's going to be the passenger train and the freight train. Okay, so we know that the passenger train goes a distance of 180 miles and the freight train goes 120. Cool. All right. Now, oh, by the way, what are we looking for? Well, the rate or the speed of the passenger train. So we'll just call that X, the rate of the passenger train. And so we, what does it say about the speed of the freight train? It says the rate of the freight train is 15 miles per hour slower than the passenger train. So the speed of the freight train is whatever the speed of the passenger train is, reduced by 15 miles per hour. All right. Now, what about the times? Well, we could just leave the question marks there and then solve this using substitution method or elimination method. But let's do this. I mean, let's just solve for t. If I divide by r on both sides of that equation, I get distance over rate equals time. And so our times can just be written as the distances divided by the rates. So for the passenger train, his distance divided by his rate. And for the freight train, his distance divided by his rate. Okay, well, that's what the formula says we're allowed to do, and it's true. So, what else do we know about the times? Well, it says that it took the same amount of time. So these times are the same, whatever they are, they're the same thing. So I can use that to set up this proportion. Okay, those times are the same. So now I've got a proportion and I can cross multiply. 180 times x minus 15 equals 120x. I just sent a whole bunch of Instagram reels to my wife and kids, so that's why you're hearing all those buzzings. They're all saying, man, it was awesome. All right, so then let's see. So if there comes a time when Instagram is no longer popular, well, then you'll know these videos are old. Okay, so I multiply the 180 through the parentheses, and I get minus 2,700 right there. I said a bunch of. Okay, now let's subtract 180x from both sides. And that'll give us negative 60x on the right side. And when we divide by negative 60, we get a positive 45. 45 what? Well, what does x stand for? Well, x is all by itself right here. And it's the rate of the passenger train, which is what we're looking for. So that will be miles per hour, and it is the final answer. And that is how you can do these. And plus, it's just really cool and it's colorful.